Hi, it's time for another math easy solution here to discuss further into trigonometric integrals, and now go over example 4 of the example series and solve this one, which is find integral of sine to the power of 4x dx. Yeah, now this function, it's not pretty straightforward of how to solve this. Yeah, but in my earlier video, we could basically we could evaluate this integral using the reduction formula I covered earlier, which is this really long equation: sine power of n of x dx equals, well, it reduces. You could reduce the sign, so this is by 1 power. Now there's by 2 here, and you keep doing it to solve it. But this is a pretty complicated method. But a better method is to use the half-angle identity formula, which I also covered in my earlier video. All the links will be in the video links below in the description, so check those out. I'll use this half-angle identity, which is sine squared of x equals 2 1/2 1 minus cos 2 of x, and this is called half-angle because this x is half the angle of 2x. Yeah, so now getting back to the function here, so sine to the power of 4 of x dx. Well, if we were to apply this half angle, we would first need to rewrite this a bit. So we will write this as sine squared of x all squared dx, just so we can apply this half angle property. So when we apply that, we have an integral now. We got 1/2 of 1 minus cos 2 of x, and this is all squared, and then there's a dx there. But since we have, we'll have a cos squared in here, so now we just evaluate this further. We get 1/4, because that's 1/2 squared, integral from, now there's this 1 minus cos 2 of x all squared, so we would expand that out. It's going to be 1 times 1 is 1. Now 1 times negative cos 2 of x, do that twice, so we add those up, 2 cos 2 of x. And now negative cos 2 of x times it by itself, that becomes a positive cos squared 2 of x dx. So that's what we get right here. So now we have a second cos, now we have a cos squared 2 of x. So we could apply the other half angle identity, which is basically cos squared of x equals to 1/2 1 plus cos 2 of x. And you could see this as well in the video link below on half angle identities. So now when we get back to over here, just bringing this back, integral from sine to the power of 4 of x dx equals 2. Now we write what we know, 1/4 integral of 1 minus 2 cos 2 of x, put a bracket there. Now we have to plus. Now because there's a 2 of x, this half angle, this is for just x, so we would have to write this as 1/2. Now this is a 1 plus cos 4 of x. Cos 4 of x, is we're just we have to double it. So this is 2 of x is half of 4 of x. And that's using this identity. This is just for x. We put a 2, become a 4x there. Now we have a d of x. So now we just have to simplify this even further. So now we get 1/4. This is a 1 minus 2 cos 2 of x. Now add this, so we'll multiply this 1/2 through, so you get plus 1/2 plus 1/2 of cos 4 of x, all bracket here, dx. Now we could solve our integral. This becomes, because now we got rid of all of the squareds, now we can just solve this. So 1/4, this integral of 1 is just x, minus integral of 2 cos 2 of x, actually 2 cos 2 of x is going to be, well, sine of 2 of x. Now using chain rule, we also have to put this underneath, because derivative of sine 2 of x, that's going to be cos 2 of x times it by 2, so we have to divide by 2. And now we have this 1/2, that's going to be, well, 1/2, that's x. Now same thing here, 1/2, this is going to be sine 4 of x. Now we have to multiply the bottom by 4, or divide by 4. And now this is, put this bracket, d of x. Now we simplify it on, actually no, erase the d of x, that's the integral, that's evaluating it. We have to add the constant, so you also have to add a constant. So now we have 1/4, and now we could add these like terms, 1/2 plus 1 here, that's going to be 3/2 of x, minus, cancel the 2, sine 2 of x. Now this is going to be plus 1/8 of sine 4 of x. And now this is just plus a constant. And now you can multiply this 1/4 in, or I'll just leave it out as it actually looks a bit simpler without multiplying it inside. And that is our answer. Yeah, and that's all for today. Hopefully you learned from this video. And in the next video I'm going to go over some guidelines on best ways of solving trig integrals. Anyways, that's all for today. If you learned from this video, like always, you can download these exact notes in the link below. Thanks for watching, and stay tuned for another math easy solution.